Here we'll consider three chromium complexes, each of the chromium 3 ion. Each complex has 5 ammonias as ligands, plus another one which we'll denote as L, and L is either chloride, water, or ammonia. Our first job is to calculate the charge on each of these complexes. We know that the ammonia is neutral, water is also neutral, chloride has a charge of -1, the chromium is at a state of +3, so the complex involving ammonia must have a 3+ charge because all of the ligands are neutral. Likewise for that involving water, again all of the ligands are neutral. But in the chloride complex, one of the ligands has a charge of -1, so that brings down the charge of the complex to 2+. Now we're told that these compounds absorb at 515, 480, and 465 nanometers respectively, and we want to predict the colors that we observe. We can do this by referring to table 18-5 in the text. We can see that the chloride complex, which absorbs between 500 and 530 nanometers, is absorbing light in the green to blue-green portions of the spectrum, and the light that we therefore observe is in the purple to red portion of the spectrum. The water complex absorbs at 480, that's absorbing blue light, and therefore the complex is observed to be orange. And the ammonia complex is absorbing in the blue to indigo portions of the spectrum, and therefore we observe light in the orange to yellow portion of the spectrum. Finally, we're going to calculate the crystal field splitting energies in kilojoules per mole for each of these. This can be calculated as Hc times Avogadro's number divided by the wavelength at which the compound absorbs. For the chloride complex, it turns out to be 232 kilojoules per mole. Note the conversion of nanometers to meters in the denominator and the conversion of joules to kilojoules. The water complex has a crystal field splitting energy of 249 kilojoules per mole. A lower wavelength of absorption corresponds to a higher splitting energy. And the ammonia complex higher still because the wavelength is lower still. And this trend in energies matches exactly the positions of these three ligands in the spectrochemical series: chloride, less than water, less than ammonia.